Alright, this video will go over creating a model in SACS, which is part of the SACS Modeling Fundamentals document, where we'll create a model in preparation for a static linear analysis. The first thing we want to do is create a folder that we'll work out of. So you can do that through your Explorer, or if you open up SACS, you click on the SACS icon. It'll open up the executive, which is shown on the screen here. And here you can see the address. You can go to wherever you want your folder to be. I have it on my C drive. And there's the icon here. You can click on that and it will create a new folder. We want to call the folder Training Project. And once we have that folder inside of there, we want to create a subfolder. So we can double click on that, create another folder here, and call it Structural Modeling. Then you'll double click on that, and this will be the folder that we're working out of. Also at the bottom of the executive here, there's a folder tab, and you can get to your folder through there also. Now you're going to click on the Program Launcher tab here, and these are the interactive programs that we'll use. So to set up, the first thing we want to do, if you click on the SACS settings in the left hand corner and you go to the unit settings, we want to work in metric kilonewtons force, so make sure you have metric kilonewton force clicked. Select OK. Then we're going to create the model, so we'll click on the first interactive program modeler. If you click on that, it brings up three options. We want to create a new model, and we'll say OK. And the first thing that'll show up is the options, and we want to start the structure definition wizard, so we'll click on that, and the units should be in metric kilonewton force, so we'll say OK. This brings up the structural definition wizard here, where we will define all the jacket dimensions, etc. So we'll be using the drawings that you should have that will accompany this. So on drawing 101 we can see what the jacket looks like. It gives a picture on the right here of a jacket and all the different stuff we'll put in, so the work point, other elevations that are in between. We have our mud line, our leg extension pile stub, pile connecting, and other elevations at the top also. So the first one, if we look at the drawings, our working point elevation, from the drawing we can see that is 4.0, so we'll input that. The pile connecting elevation is 3.0, so we'll input that. Our water depth is 79.5, and our mudline elevation, which the water is at 0, which goes all the way down, so that would be negative 79.5. Our other elevations, we can look at the drawings and we'll see the first one's at negative 50, our next one is at negative 21, the next one is at 2, then 15.3, then 23. Also notice we have checked off generate sea-state hydrodynamic data. By having this enabled, we will be able to create hydrodynamic data such as the pile and wishbone overrides. So we'll keep that checked off. Once all this is filled out, we're done with the elevations tab. Then we'll go to the next tab, which is the leg tab. So you'll click on that. The first thing is the number of legs, which is 4. And the next thing it says define coordinates at work point in batter, which is what we're going to do. So we have the drawings at the work point. We'll use that, but there's another option to do it at the mud line. So you see the row labels here. Our first X row, which is this one, is A. Our second X row is B. So we'll refer to the drawings for our A and our B, and then our first row first Y row is 1, and then our second Y row is 2. And you could change these if you wanted it to look the opposite way. Our leg type is ungrouted, which means the pile is straight through the leg without the grout. If we modeled it with the grout, it would just show one solid member together. This way, when it's ungrouted, it's going to show the leg with the pile going through it, so you'll have both members. The next thing is the leg spacing at work point. We're going to click on that. It opens up this little box, and we can see the distance Y1, which is from our A to B, or 1 to 3 on here, which is our A here and our B here. So that distance is 10, and our distance X1 distance is 15. Once we have that, we'll say OK, and it automatically defines the coordinates here. It puts the center as 0, and then we know that this was 15, so it's 7.5 on each side, and it's 10 this way, so it's 5 on each side, so positive 5 and negative 5. Then we're going to define the batter for each, so we can look at the drawings, and we know our leg 1 here. If we look at the drawings, our X batter is 0 and our Y batter is 10. For the second one here, our X batter is 10 and our Y batter is 10. For the third one here, our X batter is 0 and our Y batter is 10. And for the fourth one, it's 10 in both the X and the Y. Once we have all of that, we'll go to the next tab, which is the conductors. We'll click on Add Edit Conductor Data. The first option is the number of conductor well bays. From our drawings, we have 1, so we'll put on 1. The top conductor elevation is at the cellar deck, which is 15.3 meters. The first conductor number is 5. The number of conductors and the X direction, we have 2, and the number of conductors in the Y direction, we have 2. Then we'll look at the drawings, and from the dimensions we had on the leg tab, we'll use that and come up with the coordinates for the lower left corner. So the X coordinate for the lower left corner is negative 4.5, and the Y coordinate of the same spot is negative 1. Then we'll calculate the X between the conductors we've seen from the drawing is 2, and the Y between the conductors is also 2. The disconnected elevations, where we want it to be disconnected, we have at 4, also at 3, and the bottom at negative 79.5. And we see we have checked off disconnect at pile connecting elevation if different than working point elevation. Also keep that checked off. And this is the only 3 tabs we're going to use right now for this one, but if there's some other tabs here, the next tab is a skirt pile, which if you had a different type of structure where the piles were out on the side here instead of going through the leg, you could use this to model your jacket. The next one is the connectivity tab. We could in here define our horizontal X braces, diagonal braces through this wizard here, but we're going to define that later. The next one is sizes. You can input your sizes, your member sizes through here and automatically put it on the screen. You can see the legs, which we'll see later. It's the same label for LEG and the piles, and we could input that in here. Also, the next one is the deck girders. We will actually use this when we're defining the deck later. Once you apply this, you can come back. As long as you didn't put any loads in or anything, you could always come back and edit in here. So once we have the first 3 tabs filled out, we'll go ahead and apply it. If we hit apply, it applies what we did on the screen, but it keeps this box open. If we hit OK, it both applies it and it gets rid of the box. So if we hit apply, we'll see it. Once we hit OK, it'll close the box out. So now we see this looks like our jacket. So we want to go ahead and save this now. We'll go to File, Save As. We're saving both the model and C-state data even though we don't have any yet. We have checked off to sort the data in alphanumeric order, which will sort it versus just having it in order that you input. So we'll keep that checked off. We'll say OK. You should have the folder that we were working out of, structural modeling. If not, you can get through it through the scroll down. Our file name, we want to call it SACSJacket1Part1. Then we'll save that. The next thing we're going to do is define the leg member properties. In order to do this, we'll go to the top where it says Property, click on Member Group. We can see all the undefined groups. I'm going to show y'all there's a joint icon here. So if we click on this, it'll label all the joints. You can see all the joint names. Starts at 102L, then we got 202L, which is the labeling for the legs, and then we got 102P, 202P, that's the pile. So we have a joint for the leg, a joint for the pile, all the way up. We turn that off, we go to the next one, it's groups. We can see the groups. We got our legs and our piles here. If we go to Member, Detail, Modify, and you hover over this, you can see there's LG1 and then PL1. So that's the leg and then the pile. If you go up, you'll get to the DL6 and DL7, which is the deck leg 6, deck leg 7. And you see the middle ones are called conductors, CON. So that's the labeling that the Jacket Wizard gave us. Close that out. So we'll go back to our property member group box, and these are all the undefined groups that we have labeled here. So all these groups are labeled, but we need to define them now. So the first one we want to define is LG1. So we click on LG1. You'll see the group label here. We'll add it. It pulls up a Add Member Group box. It gives the group that we're defining, the LG1. We want the group type. If you look at the drawings, these are tubulars, so we're going to click on tubular, outside diameter, and wall thickness. Notice since we're in metric that the outside diameter is given in centimeters. Now we can go ahead and change this here to inches, and then we can input the dimensions, but also to keep the default for this to be in inches. That way we don't have to worry about constantly changing this. We'll go ahead and go to File, Settings. At the bottom it says Set User Defined Units. If you click on that, you'll see it says tubular, outside diameter, and wall thickness for member groups. It's in centimeters. We're going to change this to inches. We'll say OK. Then if we say OK, again, it's going to apply it and close this, so we'll hit OK. So if we then close this box out, we go back to LG1, we hit Add, it's now in inches. So we'll go to tubular, outside diameter, wall thickness. You just need to pay attention that you have it in the correct units that you want it to be in. Whether you change that by default or go in here and scroll through and get to it.